Welcome back, everybody. Yeah, so I started working without you guys, thinking, nah, they probably don't want to see me do more editing in Eagle libraries, messing around in spreadsheets, or I went into my ECO form and I fixed it so that when it creates a new document, it creates it as a docx. I wonder if I could do a save as and just change it to a docx. I had to Google what's the difference between a doc and a docx, and the docx has the doc is a binary file, and the docx is a more like a zipped file that contains all the supporting XML files, and that's probably why the content controls were not working that great. Like the picture was hanging up. So anyways, let's see. So save, close, and then I'll just leave 1000 alone. Oh, close that. Is it not like the naming thing? Maybe that works. Okay. Now let's just see if I click save and close on this guy. PDFs, 2nd of September, 2022. And this is indeed us. Awesome. That's great. Makes me feel good. So now we can come up to here and we can delete the 1001. Awesome. Now, so what I decided was, after looking through that TI Opamp application note, which goes back to the, like the knowledge in it goes back to the early 60s. So that's 80 years, 79 years, 80 years. Wow. So, and if a career is 20 years, that's literally 4 careers worth of, human endeavor since that was first made. So this is old stuff we're talking about. This is so let's say if you're at the beginning of your career, right? So then your dad's career, his dad's career, his dad's career, and his dad's career. So and apologize for being sexist. I'm just this is where my head is at. So anyway, so like 4 generations of career of engineers before you had this information, this knowledge. So I'm not giving y'all anything that is new or exciting. It's exciting and it's good stuff. And this is modern electrical engineering. It's definitely not post-modern, but yeah, I'm just giving it to you for the first time on a mini PCB. Okay, all right. So so the plan is to do 4 of these: inverting, non-inverting, differential, and instrumentation. And the differential, that's where it amplifies the difference between the 2 input signals, not the differentiator, just the differential. So take a subtraction and amplify it. So A times, signal 1 minus signal 2. All right, so my old example, what I did last year, which I moved over to Legacy, so 04A Legacy 2021, you could see surface mount through hole, surface mount through hole, surface mount through hole, surface mount through hole. And Did I go all the way up to instrumentation? No, I didn't. Difference? I did. I got to the, no, this is an old one. This is going back to like 2020 where, you know, I was experimenting with 4 mounting holes and then input signals over here and then output signals up at the top. And then, yeah. And in 2021, I started ripping it up and redoing it, right? So I got, so I just hadn't gotten to this one. So I got up to this one. So this is not the current standard. I shifted the holes a little bit. That's about the only, yeah. And then so, but you could see, yeah. So we can take one of these, say like the through hole one, for the inverting amplifier. We could do a save as, and then copy. Since it's a project, it knows, hey, it's a project. Select folder, and it copies it up to that folder. Now I can say set that as the active project and rename. Are you sure? Yeah, I can't rename it while I have it open. Okay. Let's see. The number I want to give this guy is 04A005. And then, yeah. So rename 04A005. And since we already had one of these last year, this is going to have to be Rev B. That's tragic, I know, but that's the way it is. Delete that. Rename, put a 5 here. Rename, put a 5 here. I wonder if I could write that script to use the file name of the script. And that way I don't have to do the replace all every time. Huh. Okay. Net list, parts list. I'm going to delete those. Well, delete. Yeah. And then delete that as well. Okay. So now we're down to this. Before we go in there and start doing all our fancy stuff, let's create an engineering change order for this guy. So 04A005. So we go to our engineering change order system, which is ECO base. We open our form, and we remember that 1002 is the next number. So I'll just put that in for right now. And then this is inverting. No, we'll just put the 04A-005, no revision, 04A-005. Current revision is going to be B. Requested by yours truly today. Description of change. Initial release. Initial release. Okay. Revision letter is B due to previously manufactured prototype. Statement of risk. No known risk. Justification of change. Product development. The picture. We'll go grab a picture of the schematic when we have it drafted. Congratulations, your document has been saved successfully. And then just to remind us all what that does, so it's saved Word document here. I changed it just before starting the video so that it saves a docx. And it created a new PDF in the PDFs folder. And the PDF is exact the document looked like when we clicked the button. And the buttons we didn't click are grayed out or disabled, and the one we clicked is the only one that's highlighted or enabled. We got a date timestamp on every page, and then a little stamp table down here that shows when the first time that any of the buttons were clicked and the document was created, the computer that this PDF was generated on, the username of the person logged into the computer, the date timestamp down to the second that the PDF was created, and the file location of the this PDF when it was first created. So this document is the record. Well, every PDF in this folder is a record. Yeah, okay. So let's go into the, before I can really get in the schematic, I needed to edit the library. So let's set that as the active project. Let's open the miniPCB library. And I already started, so if I go to, and I was having so much fun, I was like, I should really include them. I'm doing this without them. Thought I did start, but this is the, this is a 6-pin. Go to the 5-pin. All right, cool. So 5-pin, hang on a second. Wasn't this legacy a 7-pin? No, it's a 5. Okay, cool. All right, so this is the 50 by 50, but this is the 33 by 33 board because I just pasted it in here, and now we have to expand. So let's switch over to millimeters. Let's put it down at 50. Let's just give us a guideline. So there we go. That's where our border is headed to. Let's put us back on 1 millimeter grid. Let's grab the top portion of this board. Let's grab the top of the board, drag it up to there. Cool. Now let's just delete that, and let's come over here, grab this side of the board. Let's move this group over to here. That's where it's supposed to be. And we'll say delete that. Now we can go up here to this top. We have to do a little bit of math. So this should be centered on the 33. So 33 divided by 2 is 15.5. 50 divided by 2 is 25. So 15.5 minus 25 is 4.5. That's how many millimeters, that's how far this thing needs to move to be back in the center on this new size. No. Did I get that wrong? Do I not know how to do math? 33 divided by 2. No, that's not 15. And making that bigger would make that distance smaller. Oh my God, why can't I do math? So set this grid back to 25. Just put this on 25 millimeters. We'll draw a vertical line to help us as a guide. We'll put this back on 0.5 millimeters. We'll grab our logo, and we will manually eyeball halfway. So that's pretty close. Y'all can get out a ruler if you want to, but I'm gonna go with good enough. And there we go. Yep. Okay, let's double check this. 1, 2, 3, 4, and 5. cool. I think that's excellent. I think we're good. Okay. And then so if I go into miniPCB 5-pin, this is the component, and I come over to 5-pin 50 by 50, there it is. It's the updated. And then 33 is updated. 25 is old. 20 is old. This one's old. That one's old. But the 33 and the 50 are up to date. So, yay. All right. So now we can save the library. Close library. Done there. And now we can start for real. Actually, if I jump over to the board, here we go. I should be able to just hit library, update all, and then it should be the new. Different version of the schematic is already present in the file. Yeah, sure. Okay. All right, well, I didn't like something. So we're going to delete this, delete that. Oh, 25 October. It's been almost a year. miniPCB 5-pin 50 by 50. Okay. Yes. Okay, cool. All right, that was it. So that updated it. Now the board should be updated. Yep, it's updated. If y'all remember, but yeah, that's cool. I used the longer resistors on this, so that's good. Move group. This stuff right here, that's power circuitry, so we can put that up here on the power section. Nice, right? These guys, we can drag them up, kind of center them on the signal section. It is kind of crowding it. I do have wider ones, but we'll stick with this for right now. It's okay. We'll set the new schematic frame. Bam. Nice. We're cutting off at the top, so let's move group, drag this guy down to here. It's about right. Save. And ECO, we'll go to our parameters here. Circuit category, operational amplifiers. Operational amplifier. Circuits. I think it's circuits, right? I put circuits at the end. Okay. Sorry, I have to remind myself this stuff. So if I go into this PDF, just transistor amplifier. It's a printed circuit board, transistor amplifier, such circuit. Okay, cool. All right, so back into Eagle, back into the parameter. It's just a transistor. It's an operational amplifier. Circuit name, inverting amplifier circuit. Put circuit there. Okay. And then circuit variant. Previously, I called it what? What did I call it previously? So if we go to amplifiers, A, Lexi, to PNG. Previously, I called it through-hole device single supply DC bias pot. So I'm just going to call it single supply DC bias pot is the variant. Circuit variant is single supply DC bias trimmer. Drawn by me, drawn on 02 September 2022. revision is B because of my engineering change order. And Rev AECO, oh, so exciting! 1002. Nice. And the title, this is just the inverting amplifier, right? So I didn't really have a good title on my old stuff a year ago. So common emitter amplifier, so this is just going to be inverting amplifier, but I feel like circuit name, so it's an Opamp amplifier. I didn't, I put, why am I so confused? This is good. I think we do it like the, but that is the, I think circuit name is probably a little misleading, so maybe I call this dual op-amp kit, like that. And then the title is inverting amplifier. Don't I have to put the board on there? No. No, I don't need to do the board. That goes in the data sheet though. Yeah, so that'll be somewhere else. Cool. And then I wonder if I had the pinout for the op-amp. Opamp dual. Okay, that was my thing. Opamp. Info. I don't think I had a drawing. There we go. Opamp dual drawing. Oh, it doesn't quite fit. No. Well, I could make that fit. I could squeeze that. I could squeeze this. Move. This is maybe not a good idea to squeeze this so hard. Okay. So okay, well, invoke, and this one is 4x4, but if I do, we'll go 3x, and then if I did, it would still fit below, would it? I didn't space them the same, did I? Shrink that or keep it larger, but well, y'all are going to be able to learn from it, so it's for educational use only. It'll be okay. Well, I need to change revision. This guy. Revision. This is the current revision is Bravo. Okay. Awesome. Okay. So I think I want to take this MCP 2002 off. Just U1, that's power, U1A, U1B. Okay. Yeah. I really shouldn't have the SOIC on here since this is I'm going to leave that on there for you guys. Y'all are students, and maybe the first time you're you're seeing that, so it's not normal though. Okay, and I put this DC blocking cap on there last time just so it'd be AC coupled amplifier, but I'm going to take that off. We're going to go old school. We're going to let y'all just control that. In, let's be ref, let's be pot. We're going to change the reference designator for P1 to R12345. R5. We got weird stuff going on with our caps. Why is that reference designator different? 2444, and then properties 2444. So this is just did I hit the, I must have hit the near function sometime a long time ago on that. So we're going to do that and then copy that and then draw a wire from here to, okay. Oh, that's like, yeah. Okay. I'm going to move this guy schematically over by, can I copy? Move. Oh my God. Move group. We're going to put it over here. We're going to say, just delete that for now. I shouldn't put the dot up on top of that because it's rotating. Move group, just drag it one click more. Okay. So what you see going on here is these resistors and potentiometer set this voltage right here. This op-amp right here is a voltage follower or a buffer. So the voltage on the output is going to be equal to the voltage at the input, and the voltage at the input is coming from our pot. This output has this capacitor right here. I'm going to go ahead and put a resistor here too, just so you get a little RC filter thing going on there. Maybe I should, just to make it easy for you guys to read, move group, drag it all down a little bit, give it a little bit more space to breathe. Say like that. Then this guy. This will be easier to understand, most likely. Yeah, that's fine. That's good. Okay. Hmm. Mm-mm-mm. Okay, I think that's good enough. Move group. That stuff, move group up a little bit. Say to about there. That looks nice. That looks nice. Cool. Awesome. Now I can actually grab this whole little bit right here, and we'll drag it up a couple clicks. So like that. Nice. Okay. Yeah, so voltage divider, potentiometer, adjusts the bias voltage right here. This is needed so that we can do the single supply right there. So the output. So if the input is it used to be when it was AC coupled, if the input was grounded, the output would be the same as this guy. But now the input, plays with it because it's DC coupled. So yeah. So anyways, this pin right here will always be the same as this pin, which is going to be the same as this reference voltage. So the current going through here is going to need to equal the current going through here so that the voltage here just remains constant. So if this guy changes, this guy has to change. And this op-amp is what makes that happen, right? It'll push and pull. And then as it's pushing and pulling, this guy right here is going up and so, yeah. That's the 10 o'clock on a Saturday, or 10 o'clock on a Friday explanation. Okay. Yep, I like that circuit. I think this circuit is worth being a lot of people's introduction to Office. So I think that works. It's good enough. All right, let's jump over to the board and let's see what else I need to do in the library. So we use the larger resistors. That's good, but now I need to go into the library and edit those. We use the same capacitor as on the other ones, so the silk screen updated. View all. Is that all? I must have smashed this guy, so unsmash. Okay. Unsmash. Okay, cool. All right, so let's see. We can change the part number on this parameter. 005 dash Bravo. Okay. part numbers up to date. And let's go into the library, edit the library, and then we'll probably rip up all our tracing and reposition the components. Yeah, maybe drag it down from the top. Why did I squeeze it so hard on the top when I had all this extra room? Huh. Well, don't worry, it's going to be better this go around. Oh, I need to drag my nice. Cool. Cool. Okay, let's see here. Library. miniPCB. Package. This is going to be, I clicked that accidentally. Okay, this is going to be the 402, 0204 7, not 7. That's the other one. It's not a 5. That's even crazier. We're not going to use that one. That was too small. What's the V? Oh, that's vertical. That's a good one. I thought about using the vertical, save space, but you know. Is it that one? I bet it's this one, guys. Okay. Size. We need to change to millimeters. The grid can be 0.5 grid. I like to position stuff on 0.5 in the layout. So this guy can go bottom left, and then I'll just rotate it. Apply, okay. Grab, move, rotate, 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 rotate. Size, 1.5. Hey. Size, 1.5. That ratio should be 12 or 13. It's 12. Okay, make sure the layer is good. T names, cancel. T values, cancel. Width, set these widths to the 3. That was it, right? That. Cool. Okay. Save. Right click on this guy. This is T-place, but we're going to change that. Cancel. What's this guy? T-doc. So I want to do layer. T-doc. That and that. That and that. Cool. All right, cool. So now our T-place is a little thicker. That's that. Okay, cool. Okay, I think that component is good. So I should be able to come back to the board, say library, update all, and bam. So should be good now. We are going to just delete the old all right, why did oh, this must be smashed. Unsmash, and my Opamp here. This Opamp needs to have its silk screen modified too. Okay, so this is properties, DIL 08, dual inline package. With that, size 5, ratio 12. It should be T place, or not T names, okay. It should be T values, okay. That's all T. This is T place, right? Place, cancel. That's a little too close. So 0.1 millimeters, and grab the end and pop it in 1. Grab that, pop it in 1. Save. It should be okay. Let's go back to 0.5. I got that. 0.5. That's good. Okay, the origin is at the origin, at the center, centroid. And I don't know about y'all. I feel good about this though. This is good. Library, update all. Boom. Nice. Okay. Save. And time to reposition everything. You know, I'm going to rip up the group. All that. Rip up group. Bam. Okay, cool. Rats nested again, so y'all can see that the copper's still there. Cool. All right, so I can right-click properties, and I can place this guy like 25 by 25 is smack in the middle of the board. Sounds good, or that sounds good? Yeah, we'll leave it smack in the middle of the board. This guy can go like that. You can still see everything. That's kind of good there. Actually, I'm going to drag it so it, no, I'll just leave it like that. That looks fine. This guy goes over that way. So the input one, so R3 is, so this is the input. So the input's coming to here. This is the input pin. So I'll just drag it like this. Like that. And like, if I do it like this, ooh, it's close to perfect, but you know, I kind of want to take room off the top, then I'm going to do that. Do 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 do. You know what we can do? Grab these guys right here, drag them like this, grab this guy, drag it like that. This guy could stay down here. This guy could rotate where, not really, but you know, that'll be fine right there. That's good. We'll do it like that. Yeah. Okay. But I don't like how R3 and R4 have the reference designator differently there. So, and instead of smashing the components, it's going to come over here and flip one of these. So, I like, so R3 it's consistent with, so if I do this, pushes it closer to the edge. But if I do like this, then the R3 will be down there. So we'll rotate R3. Oh, that would have broken my, okay, out, net, name. This is in, I don't know, don't have to do that, but I want to, hey, I'm not supposed to cancel, save. Okay, and then this guy right here rotates like that, cool. All right, cool, nice. So those guys have a nice symmetry to them. Most of my traces are going to be on the bottom side, but seeing how these guys cross, I'm going to put this guy on the top to there, and everything else will be on the bottom. Yeah, that'll be okay. And does that go up one more click? That goes up one more click. We're going to put that there. That's good. Okay. And then these guys. So this is our, what? Oh, C7 needs to be near pin 3. Yeah, C7 needs to be near pin 3. We'll put this like that. That's fine. And then R6. Yeah. Previously we would have just had a like a little short underneath, but we put R6. That's good. Yeah, it'll be fine. This guy can go that. This guy can go like that. Put that little space in there, happening, that extra 0.5 millimeter. Let me know if that 0.5 millimeter was worth it, guys. Okay. We got plenty of room, so we'll leave y'all a little extra room. This component, this is a filter cap for power, right? Something like this, right? Should I put them closer to the edge of the board? Nah, we'll put them physically close to the chip. Okay. These guys, 1, 2, 1, 2. So I just took them 1 more millimeter further from the top there. And then should I drag the whole thing down a little? Should I just leave the pot on the edge? Yeah. Okay. Now I think we'll route this. Okay. You know how you eat an elephant? 1 bite at a time. This is an easy layout, so Whee! Okay, that's our top trace. You're trying to keep all the traces on the bottom so that the top can remain as uncut as possible to provide as good a ground plane as possible. Oops. Straight across like that? Is that a no-no? We're doing it. We're doing it. Oh, man. Oh, man. Ugh. Ugh. All right, fine. We'll just bring it off the corner like that. I don't like that either. No, I don't know. I don't know. It's weird. Take it off the side. I don't know. I put this extra lobe on there for you guys so you can probe it with a scope a little easier. I think that's why I put it there. Let's go with that, right? Let's definitely go with Nolan. Nolan was being thoughtful and kind. Never a safe bet, but you know, it's a bet we're going to take. And we're going to wrap it around this way. And then get the power line in. Stop that guy. So C5 is going to have the larger, it's going to be the larger valued capacitor. That's it. That's it. Nice. And then this may be the first time you get to see this script run, but the yellow names, those are needed to panelize it. So I have a script called refresh names, and then execute, and it inserts those names on the tnames layer. This is hard-coded, so that won't ripple. That's just text in the silk screen, so that's fine. And wow, that's how long it takes, guys. It doesn't take that long. Once you get it all set up, you just, this is why I think we can do a bunch of these boards pretty quick. Let me double check everything. Okay, P1, 1, 2, 3, 4, 5, input. Input goes to R3. Okay, not cool. This is P1 dash. Yes, this is correct. So P1 dash 1, 2, 3, ground, positive, no connect, input, output. Wow, nice. That's fine. That's fine. We'll leave it like that. We'll leave it like that. We'll leave it like that. Okay, cool. So we have ground, power, no connect, input, output. Input to here, there, right? Feedback. Wow. Output. Wow. So input, output. So all this other stuff back here, guys, is just to set the DC bias, the level of the output. All that's back there. Wow, it's great, right? This is 1960s. I'm showing you state of the art for 1963. Probably before that. This is 80-year-old stuff, guys. While this hasn't changed that much, the CAD tools that go into it have changed dramatically. The engineering processes, how people organize engineers, how people task engineers, that has changed dramatically. But like at the board, like the board itself, the circuit on the board hasn't changed much since this inverting amplifier hasn't changed much since the 60s. Okay. All right, so we're gonna run a script. We're gonna export part image. Bam. Woo, that was so nice. All right, let's go back to our schematic, which we fixed our P1. Oh, that makes me feel good that we got that right. Cool. And BA102B. This is good, good. Still not sold on it, but it's information you guys need, and I'll just put it there, so it'll be fine. It'll be fine. It'll be fine. This is a schematic image. Bam. Okay, cool. All right. Now we can close this, go back into Eagle, go here, say new board, save the board right away to 04A-005-Bravo. This is the panel. We have to go into the script because we modified this stuff, and we need to add our contour line. So back into 04B here, the script, we need to grab this. We have to change it to be 100 by 100 again. Here, and right here, and I could just copy this. I don't know why I did it the other way last time. Paste. Cool. Nice. And then 04A, paste, and 5, and all occurrences, and OK, and change the date to 02 September 2022. Okay. Works on 50 by 50. Source must already be there. Deletes everything. Rip up group at delete grid millimeter. Paste the board at here. Draw these lines. And there we go. All right. Save. Yeah. Save. Okay. Back in this panel. Script and panelize. So I need to go to amplifiers, 04A, 005, bam. Boom, there it is. Okay, rat nest, drop the component. Let's go down to miniPCB image frame. Come on. Okay, here. And that is centered. Okay, cool. Then we run this Gerber image. Export Gerber images. Nice. Save. Now we'll do the cam. File, open. Hey, it's threading the needle every time, guys. Threading the needle every time. Okay, amplifier, no, just straight up mini PCBs down here, 2-layer from August 30. Process job, because I trust myself. Meanwhile, back at the ranch, my microphone is still working, right? Yeah, working good. Whoa. Okay. Exelon, open, job, Exelon, process, bam, done. Okay, close that. All right. We are ready to 04A, 005, DRD down to GLT, right click, compress to zip. Okay, DRD down to GLTX, right click, delete. Cool. That's what China needs when they manufacture the boards for us. I hope we don't go to war with China. That's just crazy. What's the world doing these days? Just go back to work, everybody. And let's see, let's go to a data sheet. So, documents, custom office templates, miniPCB, miniPCB data sheet. This is Opamp Inverting Amplifier. Call it. Yeah, that's fine. 04A-005. That's the part number. It's in the Opamp amplifiers group. The circuit name is Inverting Amplifier. Variant description, single supply. DC bias trimmer. Board design, backspace. This is PCB 50A05. Mini PCB 04A-005. Mini PCBs, V-scored, 4 pieces per panel. We'll do that later. And I did not, I did not put those bookmarks in yet into my template. So I have to do this manually. So this is component, singular, right? Top view. Hang on a second. I'm in the schematic. Schematic 01. Add. That was there. Okay, cool. Now, this is component top view bookmark. So, component top view, component bottom view. I just love doing it the hard way, don't I? Component bottom view, save. I need to save it first, right? Yes. Just No, just give me the folder. Just give me the folder, guys. Don't do this to me. Browse. 3 clicks just so I could navigate to the place I want to put it. Here. 04A 005. Save. Save. Okay. And then this section down here is going to get all ripped up because that's for transistor amplifiers. But developer, macros, run. Perfect. Okay. Zoom in over here. The 50 millimeters. This is actual size. Do I really want it to have actual size? Size and position. It's right about 2, so I'll just leave that alone. This guy gets mirrored. Beautiful, beautiful. It's a little close to that. I draw that, yeah. It does not need to be that close to that hole. It does not. Now's the time to change it, Nolan. We're going to leave it because I'm being lazy. That's why that's there. Instead of a little bit further over. Save. Maybe we'll change it. Hang on a second. I didn't put the part number. No, I did because I copied it. No, I'll just leave it because that's the same distance spacing as on the 33 because of the way we copied it over. Okay, we'll just leave that. That's fine. Top view, bottom view, parts, images, this and that. Yeah, okay, cool. Save. File, save as, PDF. Save. Wow. And that, folks, is about how long it should probably, that's about how long it should take to make a mini PCB, because I started with the schematic already captured, but I had to do library editing because it was the first time I'd used some of these components with the new standard. So what's that, an hour maybe? Was that an hour? I don't know if that wasn't even an hour. And we're ready to order that board. Nice. Huh. And okay. All right. First Opamp. Oh, let me go back to my ECO. Let me go to the picture from file. The schematic and resize it. Ah, this is the old one. Why is this old? Mini PCB here. Got schematic 01. This guy. Delete. Okay. Yeah. Engineering change order. That. Maybe it's the fact that I have it in a table, because I know content controls and tables generally don't get along. Like weird stuff starts to happen. Or maybe it's that my laptop is 5 to 6 years old. Come on, you can do it. Is it that old though? 4 years maybe. Okay, come on. When I was 18, I got my second job, and I bought a laptop off of a friend for like $350. This is 2006, and went to my job, and then somebody asked me, "Hey, can you send out an invite for this meeting?" I was like, "Yeah, sure." So I tried to send out the invite. My laptop was just hanging up and shutting down and hanging up and shutting down, and it wasn't designed to run XP, and I just installed XP on it. And so like an hour went by, and I couldn't even send out the meeting invite for the meeting, and so I was not cool. And so the lesson I taught myself driving home from work was that frugality and patience put together equals inefficiency, and I should be less frugal if I'm going to be this patient. So that was 2006, and here I am in 2022 being patient when I probably shouldn't. I should probably upgrade my internet, upgrade my machine, and get more work done. What's going on with this? What's up with this? Why is this not? Close. Come on. Close. Oh my God. Alt F4. Save. Yeah. Save. Just gonna do me like this, Microsoft? Here it is. This is our engineering change order record, the most current for what we just did today. So we're going to make a couple more, maybe one more tonight. And then we will have 3 ready to order. And then we'll make one more. We'll have 4 ready to order. And then we'll order them. So we'll order 4, maybe twice a week, if I can keep up that pace. Or maybe I'd say, hey, 100 is not the goal. Maybe 20, 25 by the end of the year with just really documentation, really good everything. Like 25, maybe that's the real goal. Maybe that's the better goal. Like 25, and then with sales and marketing, like send some emails to professors and be like, hey, check out my channel, use my stuff, incorporate it in your curriculum. Yeah, something like that. I'm really not, this is good information, but it's too big. Maybe I should put down symbol up on top and make it more vertical. That would be better if I made it more vertical. So that's wasted space right there. So I just drag that up to the top and then put it like that, and then that would be better. Okay, well we'll probably change it like that when we before the next milestone. Spell check, inverting amplifier, printed circuit board, operational amplifier, dual op amp circuit, single supply DC bias trimmer. Okay. Anyways, I think that video, guys. I think we got it all. I think we got in, got our work done, got out, had a fun time while doing it. Let's see, how long did that take? It took 1 hour and 20 minutes. I don't know. I think that's pretty good. All right. Well, thanks for hanging out with me, and like always, y'all are troopers for sticking around for so long. So I appreciate that, and we'll see you in the next video. Laters.